In computer science, a search algorithm is an algorithm for finding an item with specified properties among a collection of items. The items may be stored individually as records in a database, or may be elements of a search space defined by a mathematical formula or procedure, such as the roots of an equation with integer variables, or a combination of the two, such as the Hamiltonian circuits of a graph. Classes of search algorithms. For virtual search spaces, algorithms for searching virtual spaces are used in constraint satisfaction problem, where the goal is to find a set of value assignments to certain variables that will satisfy specific mathematical equations and inequations. They are also used when the goal is to find a variable assignment that will maximize or minimize a certain function of those variables. Algorithms for these problems include the basic brute force search, and a variety of heuristics that try to exploit partial knowledge about structure of the space, such as linear relaxation, constraint generation, and constraint propagation. An important subclass are the local search methods, that view the elements of the search space as the vertices of a graph, with edges defined by a set of heuristics applicable to the case, and scan the space by moving from item to item along the edges, for example according to the steepest descent or best first criterion, or in a stochastic search. This category includes a great variety of general meta-heuristic methods, such as simulated annealing, taboo search, A-teams, and genetic programming, that combine arbitrary heuristics in specific ways. This class also includes various tree search algorithms, that view the elements as vertices of a tree, and traverse that tree in some special order. Examples of the latter include the exhaustive methods such as depth-first search and breadth-first search, as well as various heuristic-based search tree pruning methods such as backtracking and branch and bound. Unlike general meta-heuristics, which at best work only in a probabilistic sense, many of these tree search methods are guaranteed to find the exact or optimal solution, if given enough time. Another important subclass consists of algorithms for exploring the game tree of multiple-player games, such as chess or backgammon, whose nodes consist of all possible game situations that could result from the current situation. The goal in these problems is to find the move that provides the best chance of a win, taking into account all possible moves of the opponent. Similar problems occur when humans or machines have to make successive decisions whose outcomes are not entirely under one's control, such as in robot guidance or in marketing, financial or military strategy planning. This kind of problem, combinatorial search, has been extensively studied in the context of artificial intelligence. Examples of algorithms for this class are the minimax algorithm, alpha-beta pruning, and the A algorithm. For substructures of a given structure, the name combinatorial search is generally used for algorithms that look for a specific substructure of a given discrete structure, such as a graph, a string, a finite group, and so on. The term combinatorial optimization is typically used when the goal is to find a substructure with a maximum value of some parameter. An important and extensively studied subclass are the graph algorithms, in particular graph traversal algorithms, for finding specific substructures in a given graph such as subgraphs, paths, circuits, and so on. Examples include Dijkstra's algorithm, Kruskal's algorithm, the nearest neighbor algorithm, and Prim's algorithm. Another important subclass of this category are the string searching algorithms, that search for patterns within strings. Two famous examples are the Boyer-Moore-Noether-Maurizer-Pratt algorithms, and several algorithms based on the suffix tree data structure. Search for the maximum of a function. In 1953 J. Kiefer devised Fibonacci Search, which can be used to find the maximum of a unimodal function and has many other applications in computer science. For quantum computers, there are also search methods designed for quantum computers, like Grover's algorithm, that are theoretically faster than linear or brute force search even without the help of data structures or heuristics. See also, category, search algorithms, backward search, content addressable memory hardware, web searching for example, Google's PageRank, Solver, search games. Recommender systems also use statistical methods to rank results and very large data sets. Sorting algorithms necessary for executing certain search algorithms, selection algorithm, no free lunch in search and optimization, search engine, linear search problem, string searching algorithm, references, Donald Knuth. The Art of Computer Programming. Volume 3, Sorting and Searching. ISBN 0-201-89685-0. External links, Uninformed Search Project at the Wikiversity. Unsorted Data Searching Using Modulated Database.